All right, so we want to find the roots of this polynomial, and what's the degree of the polynomial? 4. 4. So we should have how many roots? 4. Now that doesn't mean necessarily 4 distinct roots, right? Because we could have multiplicities of either 1, 2, or 3. And it's not even guaranteed that we're going to have a real root, right? Because the fourth degree has the same end behavior. So this one, what's the right end behavior of this polynomial? What's the limit as x goes to infinity? Positive infinity. And what's the left end behavior? Also positive infinity, right? Even degree polynomials have the same end behavior. What's the Y-intercept? 70. Yeah. Let's do something else here that I'm going to ask you on the test tomorrow, which I didn't ask you here. List the possible distinct rational roots and tell me how many possible distinct rational roots there are. So remember, it's going to be of the form P over Q, where P is a factor of the constant and Q is a factor of the leading coefficient. So 70, how many factors does 70 have? Well, let's see. Plus or minus 1, plus or minus 70. Plus or minus 2, plus or minus 35. How about 3? Does 3 go into it? No. 4? How about 4? No. How about 5? Yeah, so plus or minus 5. And what? 13? 14. Yeah, 14. Plus or minus 14. 6? How about 6? No. How about 7? Whew. 7 plus or minus and plus or minus 10. So 8, 9, no. 10 we already got. 11, how about 12? 12, no. 13, no. 14, 14. Yeah, I already got 15? No. 16. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Already got it. Okay, so once you get to half the number, you're done. So those are all of them. That's not too many. And then 2, there's plus or minus 1, plus or minus 2. So, man, let's just write them all out. Remember, with Notability, you can kind of, not cheat, but be smart. It's going to be all of those over 1, so it's going to be all of those. So they're going to be of the form P over Q. And all of those over 1, and then we have all of those over 2. So then plus you, bless you, Nolan sneezed, if you're wondering who that was. Plus or minus 1/2, plus or minus, let's see if we do even have to write these down. The next one's going to be 70 halves, also known as what? 35. Do you already have it? Yep, so we don't have to do that. Then plus or minus 2 halves, that's known as 1. We already have it. How about 35 halves? Do we have that one yet? Nope, so he's unique. We'll write him down. And then plus or minus, the next one will be 5 halves. We don't have that one yet. And then the next one will be plus or minus 14 halves. We have that one already. Yeah, it's known as 7. And the next one is 7 halves, which we need. Plus or minus 7 halves. And then finally plus or minus 10 halves, which is also known as 5, and we already have it. So these then are the possible rational roots. Which of those are guaranteed to work? Which ones? None. None are guaranteed to work. In fact, because it's a fourth degree polynomial with rational coefficients, we know that all the solutions could be, right now, rational, right? 2 pairs of conjugate irrationals. But if they are any rational solutions, they're going to be one of those. And how many are those? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. And then 9, 10, 11, 12 positives and 12 negatives. So a total of 24 possible, distinct, rational, a lot of adjectives here, roots or zeros. 24 possible. So you would be elated then if you only had 24 things to try using synthetic division as opposed to infinity. Now, we don't have to do that, right? Because I gave you enough information so that you can get down to a quadratic. And then, of course, once you get to a quadratic, factor it or use a formula. All right, so let's go ahead and do the process then. If the square root of 7 is a root, what else must be a root? Negative square root of 7. So I already have these roots, which are positive square root of 7 and negative square root of 7. Do those show up in this candidate list right here? Why not? They're irrational, right? And this is the rational root theorem. So it says if you got rational solutions, they're going to look like that. These are two irrational solutions. So let's go ahead and do the synthetic division. And step 1 is to write down the coefficients in descending order. Careful to have a placeholder for anything that's missing, yeah? So from left to right, I'm going to leave a little more space than usual. So a 2, x to the 4th, what comes next? Negative 1, x cubed, what comes next? Ooh, negative 24. Did any of y'all write down 7 first without thinking? I got you, right. But then you got it, you said. That's what you meant by I got it? I tricked you, okay, because it wouldn't work. And then a 7, and then a 70. So if you want to actually physically rewrite your polynomial in descending order so that you could do that, maybe adding zeros if necessary, that's fine, or just write them down in order. Okay, so let's go ahead and synthetically divide. Which one do you want to use first? Positive square root of 7. Me too. Positive square root of 7. Step 1, bring the 2 down. We got a 2 there. Multiply, you get 2 square root of 7. And just as early as yesterday, or even the day before maybe, some of y'all would call that 1 square root of 7, right? But not anymore. Now we know that those are unlike terms, and we call that just 2 square root of 7 minus 1, or negative 1 plus 2 square root of 7. Now we multiply, and we have to distribute, yeah? So what do we get in the first term? 14 minus square root of 7. Then we add vertically, and we get negative 10. We combine the numbers, and then minus the square root of 7. Do it again. Square root of 7 times negative 10 is negative 10. Square root of 7 minus what? 7. 7's cancel, and we're left with negative 10 square root of 7, which when we multiply by another square root of 7 gives us negative 70. And we actually did the math, and now it turns out that we do get a 0 there. So that means that we are doing it how? Correctly. Gleefully would be another good adverb. Bless you. That one was not Nolan. All right. Negative square root of 7. Bring down the 2. And then you multiply, you get negative 2 square root of 7. You add, you get negative 1. Multiply, you get positive square root of 7. Add, you get negative 10. Multiply, you get 10 square root of 7. Add, and you get 0. Yay! And so if we started with a 4th degree polynomial, the first depressed polynomial would be degree 3. The next depressed polynomial is degree 2. So we're staring at our quadratic. So we know that 2x squared minus 1x minus 10 has to equal 0. And I do want to see that, if this were a test tomorrow, that you're setting that last thing equal to 0. Because now there's an equation to solve. And you could use the quadratic formula, right? Just get right to the quadratic formula and don't mess around. But you could also attempt to factor it, either by, target sum, target product, and splitting the middle term, or just realizing 2 is prime. So if it's going to work, it's got to be a 2x and an x. And it's probably not going to be a 10-1 combo on the factors of 10 because our middle term is negative 1, so it's got to be something closer. So maybe a 5-2. So maybe a 2 there and a 5 there, and minus 5 plus 2. Yeah, and then, of course, just FOIL it out real quickly and check. So from there, you don't even have to list the solutions to those two because you should be able to look at those and tell me what the roots are. And so now we'll write this summative statement. So, comma, and y'all want to use the passive voice or the active voice? Active. So f of x is, apostrophe s, roots are, and again, dot, dot, dot is kind of suspenseful, kind of like last night. X equals, and then we'll list our conjugate pairs. You could say plus or minus the square root of 7. Do we need to list the positive square root of 7 since I gave it to you? Absolutely you do, because it's one of the ALL roots. And then we've got the 2x minus 5. Oh, my gosh, that's going to give me a negative 2/5, a negative 5/2. I forget, what is it? Positive 5/2, yeah. So if you need to go off to the side and set that equal to 0 on your bench, do so. I'd rather you do that than look at it and get it wrong. Now, x plus 2, hopefully you look at and know the answer is not 2, but negative 2. All right, now quickly take one last inventory. How many roots do we have here? 4. What was the degree of the polynomial? 4, so we're done looking, right? And those are all multiplicity what? 1s. Yeah. Can we sketch the graph? Yeah, I think we can. Let's go for it, okay? Of course, we're going to need a y-axis and an x-axis. So there they are. And let's just go ahead and put these values on the axes. I'll use like a pretty dark turquoise here. Square root of 7 is about what? As between which two integers? 2 and 3. So here's 1, 2, 3. 1, 2, 3. It's like we're polka dancing. Where's fast? 1, 2, 3. 1, 2, 3. So negative square root of 7 is going to be right about here. Negative square root of 7. Positive square root of 7 is going to be right around here. Uh-oh. 5 halves is about what? 2.5. Oh, that's going to be really, really close to the square root of 7, isn't it? Which one's bigger? 5 halves? Yeah. That's going to be really close. I don't think I'd give you one like this on the test and ask you to sketch it because there's definitely some ambiguity there. No, they're all multiplicities of 1 because there's 4 distinct roots. And it's a degree 4 polynomial. All right, the square root of 7 is about 2.6. So, oh man, this is going to be kind of tricky. Yeah, here, let's do this. Whoa, there went my x-axis. I hate when that happens. Okay, I'm just going to put this here and call it the square root of 7. And I'm going to put this here. I'm going to exaggerate the difference a little bit and call it 5 halves. Maybe not the best one to sketch. But, hey, we can make it happen, right? It's not over until the final votes come in. And then, oh, my God, and then negative 2. So these are all really, really close together. Tight-knit root family. Okay, so we said that it's a 4th degree polynomial with a positive leading coefficient. So we know both end behaviors are what? Positive infinity, and those are all crosses. Now, one last point. The y-intercept was what? What did we say? 70. Wow. Okay. How are we going to communicate 70? Well, I'll show you. Let me take this. Let me move it down here. And then we'll come here and we'll redraw, kind of remodel. Yeah. And then we'll put a value right here. I'm just going to call that 70. What the heck? And now, here we go. Here we go. We're going to come in the top. And we're going to turn quickly and come up at 2. And then we're going to pass through 70. Make the dot bigger if you miss it. That's a nice little trick. And then you come straight down, almost vertically, and then quickly turn the corner. Don't go too low. And then do that. Does this function have y-axis symmetry? I sure drew it like it almost could have. No. The conjugate roots, of course, are symmetrical, but negative 2 and 5 halves are not symmetrical roots. And the local max is not necessarily at the y-intercept either. How could you verify and prove that it was not y-axis symmetrical? Right, yeah, you can actually do it by the symmetry of the roots. You can even do the algebraic test, right? When you plug in a negative x for x, the first term, 2x to the 4th, is going to stay the same sign, and the second term, x cubed, is going to change signs, right? So it's neither even nor odd.
Can you show kind of if it does not actually have to use the quadratic formula?
Oh,
like, I know
sure, absolutely. Let's go ahead and get the same answers by the quadratic formula. I like that. Because might you have the quadratic formula on the test?
Yeah.
Heck yeah. Heck yeah. Okay, so you want to write it in descending order of degree, which it is. And you might want to put like a 1 here so you can kind of see the coefficient. So ax squared plus bx plus c is the standard form when it's equal to 0. And then the solutions are x equals the opposite of b plus or minus the square root of b squared minus 4ac all over twice a. So in our problem, a is equal to 2, b is equal to negative 1, and c señor is equal to negative 10, menos 10. ¿Verdad? Sí, muy bien. All right, so now it's just a plug and chug. X equals the opposite of b. What's the opposite of negative 1? Positive 1. Plus or minus, there's your conjugate irrational root built into the system. The square root of b squared, well, that's going to be positive 1. Minus 4 times a is 8, times c is going to be negative 80. So minus negative 80 makes it plus 80. Oh, yeah, let's go in baby steps then. Minus 4, that's okay, times a, which is 2, times c, which is negative 10. All over twice a is twice 2. So now when you simplify that, you get plus or minus. That's going to be, inside, that's going to be 81. All over 4. And then all we have to do is simplify. The square root of 81, is that a perfect square? I think so. It's called 9. So now you get 1 plus or minus 9 over 4. Now, those are not the best versions of the numbers. So let's go ahead and list it as 2 numbers. Let's do the plus first. It's either 1 plus 9, which is 10 over 4. 10 fourths, of course, simplifies down to 5 halves. 10 fourths also is means A-OK on the CV radio. And we got 1 minus 9, which is negative 8. And then negative 8 divided by 4 is minus 2. So you can get the answers that way every time. The good old quadratic formula. Of course, y'all know where that comes from, right? It's not from France. It actually comes from completing the square on this general form of a polynomial, which I'm sure y'all have seen before, right, in your Algebra 2 class, or Algebra 1 at least. All right, maybe some other rainy day I'll show it to you, because it's kind of neat. What else can we talk about this function? Anything? Oh, yeah. How many local extrema does it end up having? It ended up having 3 local extrema. Was that the maximum number it could have had? Yeah. And how many roots did it end up having? 4, which was the maximum number it could have had. Yeah. How about this? Let's answer this question. Last one, and then we'll move on.
Teachers, please.
That's us.
Interruption at this time. Please release Ms. Melissa's students on the email.
Oh, they're going to
area, please.
Verstenfesten. What's that? General limit. 70. Good. Good. Where are polynomials continuous? What's the domain of polynomials? All real numbers. So polynomials are continuous for all real numbers. They don't have any holes. They don't have any jumps. They don't have any asymptotes. So remember, if a function is continuous, the general limit is the same as the function value, right? Road breeds road. And so if you have to evaluate a limit at a polynomial, you just find the function value. So direct substitution, right? Would the domain would be an easy question. What is the domain of this function? We just said it. All real numbers, so the double bar R. Would the range be a fair question for me to ask you on this one? No. No, it would not be. Because we know it's bounded below, but I don't know what the local minimum value is at each of those turning points. I don't even know the x value where they occur. One of them might be lower than the other, but it's definitely bounded below. So that would not be a fair question unless, A, I gave you a calculator, which you won't have on the test tomorrow, or B, you know calculus, which this is called pre-calculus. So, all right, any other comments or questions about this one? All right, any questions at home? Yeah, speak louder, because you're not only having to speak from your house to the high school, but you got to speak through the time warp. You have to go back in time. Okay, I didn't hear anything. What? All right, let us switch gears then. Okay, for the test, how may you prepare? You may prepare any way you like, but you might want to start preparing a little bit differently if you're not getting the results that you want on the exam. So remember, it's about memorizing, bless you, certain theorems, certain ideas, certain concepts, and then practice, 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 okay? And as I mentioned yesterday, you're going to have to be pretty proficient with your synthetic division. Otherwise, you're going to risk not being able to finish the test. So at the very top there, it says links to old tests right there. I should probably say former tests because I don't want the test to have their feelings hurt. Hey, I'm not old, you know. All right. Y'all are doing 3-1. Y'all are the Precal here, and you're doing 3-1 to 3-2. But notice there is no 3-1 to 3-2. So there is a 3-1 to 3-4, and I just posted the key for the 2013 examination just last night. The 2013 and 14 tests are very similar. As a matter of preparing, I would put aside 50 minutes and see if you can complete the 2013 test, and then check with the key to see if you've done it correctly. Anything that involves an I, you do not have to worry about. But if you want to kind of think about it, there is a theorem that we're going to talk about called the complex conjugate theorem, which means if you have an imaginary root, just like the radicals, it's going to come in conjugate pairs. So in other words, if 2 plus I is a root, 2 minus I will also be a root. And that will allow you to answer a couple more questions on here. But I won't test you over that. So let me import this. Create a new note. We'll select all the pages. There it is. And what folder am I in? Warm-ups. Nice. Okay. That'll work. So here's the key that I put last night. And I put the explanations here. You're going to have a little bit more room than this on your test tomorrow to work. But number one, definitely. So if you want to know which ones for sure will be on your test, because I did have this open as I made the new test. Number one, for sure, for sure, for sure. You're going to have basically 4 roots for a polynomial, kind of like what we just did. And I'm going to ask you for the product, RST, TV. Number 2, you're not going to have. Okay, number 2 is powers of imaginaries. So this one, let's do this. We'll go with red. This one is not going to be on the test. Number 3, fantastic question. Number 3 is good. It's golden. I like these questions because you do have to kind of read all of them, and they're kind of theory-based. Which one must be true? Make sure you read that carefully because sometimes it says which one must be true, which one is not true, bless you. And remember, to be true in math, it has to be true all the time, not just some of the time. So, for instance, which must be true about a polynomial of even degree? Is it an even function? Remember, even degree refers to the type of number the largest exponent is. But an even function refers to what? Symmetry, y-axis symmetry. So does every 4th degree polynomial have y-axis symmetry? No. So I put it can, but not always. So there's my explanation. That's always be true. Okay, number 4, a linear factor is of that cubic is x plus 1 and what other. I got rid of the word possible because that threw some people off. But there's 2 other factors, and which one of them should be listed. So that's a real easy synthetic division thing. I like that one for y'all's test. The value of k that will make x plus 1 a factor, oh, that's a good one. Because remember, you can use the remainder theorem there. If x plus 1 is a factor, what's the associated root? -1. So all you got to do is plug in a -1 for x, and you can do it synthetically or directly, and set it equal to what in the magical number? 0. And then solve for k. Piece of cake. So I like that one as well. That's a good one. 6, I think I mentioned if you have room to put several asterisks by, this would be the one to put purple snowflakes by. That's pretty. I can see why a lot of people do art on here. I like this one a lot. Now this one here is a, let's count the roots, okay? You got a bounce here, so that counts for 2. You got a cross there, that counts for 1. And you got a cross here, that counts for another 1. So there's 4 roots. So this is a 4th degree polynomial. And notice because it opens down, the leading coefficient has to be negative. So if you're going to write an equation for this, this is -2 m2. That's a 0 m1. That's 2 m1. So now writing the equation, let me zoom in. and this is how I would do a problem like this. Just write the equation. Give it a name like y. You know the right-hand behavior is negative, so you're going to put a negative out front. If 0 is a root, then x minus 0 or just x is a factor, and because it's an m1, it's to the first. Here's where you're going to get maybe bogged down because these are going to be symmetrical roots, and they're going to be doing different things there, so you can't get them confused. Negative 2 is a bounce, so it's x plus 2 squared. Positive 2 is a cross, so it's x minus 2 to the first. And believe me, there's an answer choice that has it the other way around, x plus 2 to the first and x minus 2 squared. So make sure that you know that if 2 is a root, x minus 2 is a factor. Now this, look to see if it's an answer choice, right? You create the equation, look to see if it's an answer choice, and you first gravitate to the ones that have the negative in front. And you're like, oh, that could be it, but no, that's x squared, so that's not going to work. What happened there? Oh, okay. You then look, maybe this one has a negative in front, so maybe that's it. And a lot of people that took this test in 2013 shows that answer, and they got it what? Right or wrong? Wrong. Because it looks like it should be the correct one, but notice your x plus and minus 2 factors have the wrong exponents on them. Tricky, tricky. So then someone maybe raise their hand and say, sir, the correct answer is not here. It's got to be negative, and the 2 with the negative in front, they don't match. And I'm like, look harder. Look harder. So what do you mean look harder? Well, if you notice, this is 2 minus x. And we're having a hard time here. There we go. If you factored out a negative just from that one factor, you get negative 2 plus x, which is the same as x minus 2. So there you go. When you see a 2 minus x factor, that means that the negative has been now included inside one of those. So now it can't be this one for a couple of reasons. There's 2 negatives, which means it's really a positive. So if you come back over here, the x plus 2 is supposed to be squared. There's an x plus 2 squared. There's an x to the first. And here is an x minus 2 to the first with a negative distributed in. So tricky, tricky. And if you know to look for that, then you got it made. Well, yeah, right here, if you pull out a negative from here, you can put it at the front. And you can call it negative x plus 2 squared, and then that becomes x minus 2. And that's exactly what we wrote. So it's, in other words, you can take the one we wrote and take the negative and just distribute it inside there. So it's kind of disguised. Okay, so that's a good one. Lots of purple snowflakes. Yeah. Who knows? I might give you some choices that have it disguised, but will that be the correct answer? Reverse psychology? I don't know. As long as you know what you're doing, the right answer will be there. How about that? Okay. I love number 7. However, you're not going to have this right on there. See how this says I plus 1 is a root? That's not on 3.1 to 3.2. But just so you know, it's like the radical conjugate theorem. It's the complex conjugate theorem. If I plus 1 is a root, then negative I plus 1 is also a root. So if I give you a question like this, you're just going to have, rational numbers or irrational numbers. And the irrational ones come in pairs. So if square root of 2 plus 1 is a root, so is negative square root of 2 plus 1, which when you flip it around is 1 minus the square root of 2, which is b. All right? What's that? No, I squared is negative 1. Yeah. Okay, I like number 8 as well. We did a couple problems like that in warm-ups. We did one in the worksheet. What's the remainder when you divide by a factor? Remember, the remainder is nothing more than the function evaluated at the root of the factor, right? So if x is the factor, 0 is the associated root. Direct substitution is probably an easier way to go than synthetic substitution. And it says right there, it says if x is a factor, x equals 0 is the root. So f of 0 equals the remainder. So I showed a lot of work, so you could actually look at it, process what I'm doing, and learn from it. Of course, 9 is another fantastic one. I love it because that requires you to set up a whole equation in general form. Of course, I'm not going to give you a factor of I, but I'll give you something. And then you'll have to plug in the value that's not on the y-axis, or the x-axis, sorry. This one's the y-intercept, and then find the value of a. And that's what this one is asking for. So I did it with the i's here. I is a root, so negative I is a factor. And the only thing that you need to worry about in terms of I, if you wanted to do it, is I squared is equal to negative 1. So x minus I and x plus I is x minus I squared. But because I squared is negative 1, it turns into x squared plus 1. But that's what we're doing on the next test. So yours won't have imaginary roots at all. And I love, love, love number 10. Because it's a simple question. How many relative extrema does the function have? But it does require you to sketch the graph to figure it out. And then you count them. So that basically knows the test. Do you know your multiplicities 1, 2, and 3? Now notice if it says it's an 8th degree polynomial, when I ask how many does it have, I'm not asking for the maximum possible number that it has. I'm asking for how many does that function actually have, not the possibles, okay? So you actually have to graph it and count them. And that one has 5. You know it has to be an odd number, right? So if it's an 8th degree polynomial, it has to be 7, 5, 3, or 1. So you can get rid of the 6 and the 4 right away if you're just guessing, but hopefully you don't guess, right? And that takes care of it. I highlighted, well, all of them except one. I think y'all have 9 multiple choice questions. So could it be very similar to those 9 purple ones? Yeah. And then the last one here, again, very, very similar to what you're going to be asked to do, except the only difference here is I give an imaginary root here, and you're not going to have imaginary roots. But it's kind of like what we just did, plus all the extra questions. So the warm-up that we just did is very, very similar. I might ask for the range. If I ask for the range, it's going to be a fair question. For the range? Well, if I ask you for the range, it's going to be a fair question. The one that we just did, asking for the range in the warm-up, was not a fair question because we didn't know what the boundary was below. When is the range a fair question for now? If it's an even degree polynomial, the end behaviors are the same. Well, the domain for all polynomials is all real numbers. There's only one time for one specific type, an odd degree polynomial. That's the only time the range is a fair question. And then the answer is what? All real numbers. Totally fair. No remainder and the quotient and the divisor. None of those. We're going to do those on the next one. P, D, Q. Yeah. Now, here's the synthetic division all worked out. And I was practicing with my new Notability Snap a Line feature, trying to make it kind of smooth and straight. And it was very enjoyable. I had a good time doing it. Now, this one here, because it went through 3.4 where we had more practice, the polynomial that comes out in the end, 2x squared minus 12x minus 6, when you factor out the 2, you try to factor this and it doesn't work. So on this particular test, we had to use the quadratic formula. And rather than use the quadratic formula with a 2, a negative 12, and a negative 6, which makes the numbers bigger, you can just use a 1, a negative 6, and a negative 1. And that's what I did. And so we came up with 2 more conjugate irrational solutions. What? Oh, yeah, I'm an idiot. I did that. I'm pretty good at doing that. That is getting to the end of the work and then celebrating in my head too early and then making a careless mistake. Yeah, that should be a 3. That should be a 3. Let's go ahead and fix it right now since you brought it up. And this will give us more practice with the quadratic formula. So, nice. All right. Oh, I can't do that because How y'all doing? I have to go to the actual document. Okay, here we are. So that would be a 3. Okay, so 3. Now, do as I say, not as I always do. When you factor out the 2, double check. 2 times negative 3, negative 6. Got it. Now, does that one factor? Maybe that one factors. Factors of 3 that add up to 6? No. So now we use the quadratic formula. A is 1, B is -6, and C is -3. So we get the opposite of B, which is still +6, plus or minus B squared. Now be careful when you B squared, because some people write -6 squared there, and they get lazy and they write it like this, -6 squared, and then guess what they write after that? -36, which is not correct. So just tell yourself, hey, when I square a negative number, it's going to be positive, so don't even get the negative involved. -4 times A, which is 4, times C, which is, there it is, -3. And so now that turns out to be a 36 plus 12, which is what? We get 6 plus or minus 36 plus 12? 48. Yeah, over 2. Now, is 48 a perfect square? No, but does it have a factor that is? Yeah, it's 16 times 3. And remember, if you have to do that, you could do your upside-down birthday cake. 2, 24, 2, 12, 2, 6, 2, 3, 3, 1. And there it is. So remember, it takes a pair of factors on the inside to make one on the outside. So I have 2 pairs of 2, so I can pull a 2 out from here and a 2 out from there, which makes it a 4. And then anything that's left is still inside. So this becomes 6 plus or minus 4 square root of 3 all over 2, which when you split them up and put each of them over 2, don't tell me 6 divided by 2 is not 1. It's 3 plus or minus 4 halves is 2 square root of 3. So there are the final 2 answers. And then we'll just fix these over here. And I'm so embarrassed. I feel like Hillary Clinton. Oh, sorry. Too soon. Too soon. Yeah. But I made that little mistake. Yeah. Okay. And there they are. And so I have 1, 2, 3, 4, 5, 6, 7 roots. What was the degree? 7. Notice it wasn't written in. Ooh, it wasn't written in the right form. So I got all my roots and I'm done. I hear them yelling next door. They're having a good time. Y'all ever get jealous that you're not next door? No. Hey, I can't think of anything else to tell you without giving the test away practically. Huh? Look under your desk. You got a gold-plated test with the answers all pre-bubbled in. Have a nice life. I hope it doesn't get difficult for you because you've never had adversity and you don't know how to deal with it. All right, so there you go. Practice, practice, and practice some more. I would start with the 2013 test, look at the key, try the 2014 test, do the similar results. You wrote down the warm-up from today. You can watch this video because I'm going to upload it in the shared folder. And it'll go through everything, including the warm-up again. So I'm hoping that everyone makes 100 on this one so that I don't have to do any type of curve or adjusting. That would be awesome. In fact, I think I made this deal with y'all before. If everyone makes 100, I will give everyone a 105. I'll add 5 points to everyone's test. So do your part. Support the team. Well, I need to talk to Ms. Lincoln about how that's going to work. Yeah. But I'm talking about test specific, not like can specific. Yes, sir, Randall. Yeah, I'm checking. We're looking into that. She did win for her group, so we'll have to do like a little math conversion, cans to green beans to cans conversion or something.